So the next couple of problems here all deal with this logarithmic function y equals the log of 7x plus 9 minus 2. Log is, in this case, base 10, since it's common log and it's understood to be base 10. Okay, so find the domain of this function on number 12. So finding the domain, remember that I can't take the log of anything negative. It's got to be greater than 0. So I take what's inside the parentheses there, 7x plus 9, and set it greater than 0. And now I just have to solve this thing for x. So subtract the 9 over. When I subtract it, 7x is greater than a negative 9. That was a common mistake that some people left off their negative. And then finally divide it by 7, so x is greater than negative 9/7. You can put this in set builder notation thusly, or you can put this in interval notation, negative 9/7 to infinity. Okay, so there we go. Like so. Okay, number 13. Find the x-intercept of, and it's the same logarithmic equation. X-intercept means that a y is going to be equal to 0. So just plug a 0 in here. Log of 7x plus 9 minus 2. So we're going to write this in exponential form, but before I can do that, I need to get this logarithmic term by itself. So I've got to add the 2 over to the other side. And now, in order to solve it for x, I have to exponentiate or write it in exponential form. So again, this is a base 2. This is an answer to a logarithm. Answer to a logarithm is a power. It's an exponent. It's a power on the base of 10. So 10 to the second power is equal to whatever I'm taking the log of, 7x plus 9. Okay, so 10 squared. 10 squared is 100 equals 7x plus 9. And then I want to subtract the 1 over. I get 91 is equal to 7x. And then finally divide by 7. So x is equal to, and 7 goes in there exactly 13 times. So your x-intercept is 13, 0. There we go. Alright, so the next two problems, still dealing with the same equation. So we're going to write this in exponential form. Remember that a logarithm and an exponential, there's two relationships here. It is both exponential and it's an inverse of an exponential. It's just depending on whether you switch the x and the y coordinates. So, on number 14, writing in an exponential form, let me go ahead and write the equation down again. Log of 7x plus 9 minus 2. In order to write it into exponential form, we have to first isolate the log term. So let's get the 2 over to the left-hand side. So y plus 2. And that was a common mistake that some people had the same sign as in it was y minus 2 equals the log of 7x plus 9. This is an answer to a logarithm. The answer to a logarithm is an exponent, and specifically it's an exponent on the base of 10. So 10 to the y plus 2 power is equal to whatever we're taking the log of, 7x plus 9. There were a couple of people who left the answer like that, and that's acceptable, but I like to solve this thing for x. So solving it for x, let's get the 9 over here. So 10 to the y plus 2 power minus 9 is equal to 7x. And then finally, let's divide by 7, or take a seventh of this. And so I have 1/7 times 10 to the y plus 2, all of this minus 9, is equal to x. So here is this logarithmic equation written in exponential form. Now number 15 is a piece of cake, because what does an inverse do to a function? Well, it switches the x and y, and if you have a logarithmic, its inverse is always exponential. So I take this and switch the x and the y. So I'm going to make it y is equal to 1/7 of 10 to the x plus 2 minus 9. And you're done. Ta-da!